This is the fifth video in an overview series of the first 3 chapters of the book From Quantity to Number, a first course in mathematics. This book is for parents and students interested in a discussion-based math program for their homeschool curriculum. For more information, see inletbooks.com. This video features some of the ideas in Chapter 3 on addition, but first we will start with a very quick look at Chapter 2, Numbers. Chapter 2 is an idea planting chapter. It is not a deep dive chapter. Rather, we want to alert the student to the notion that our idea of number will evolve and that this is interesting and a lot of fun. We will show this in discussions of different kinds of numbers, all while continuing to consolidate the understanding developed in Chapter 1. The expectation is that the student would be practicing the ideas of Chapter 1 in the assignment sessions, and the discussion topics of Chapter 2 can serve to preview subsequent discussions. Check out the book's preface available at inletbooks.com for more guidance on the assignments. In Chapter 1, we learned how to understand and how to write numbers, including numbers even into the millions. We learned about the powers of 10 and how the digits of a number indicate the count of each power of 10 and hence the meaning of a number. Now we can understand, for example, the number 1,762,543. The sections in Chapter 2 discuss different characteristics of number that will emerge as we work with numbers more. These help us to develop a more refined understanding of number. Chapter 2 looks in particular at negative numbers, where we characterize numbers with direction as well as magnitude. We also look at rational numbers and other kinds of numbers, just to note this idea that we can extend our understanding of number as we discover new characteristics that are helpful in describing the relationships that arise in arithmetic. But let's go ahead and start up on Chapter 3, Addition. This is the intuitive next step after beginning counting. We can approach addition by taking a thread from our discussions in Chapter 1. It's the idea of adding 1 or incrementation by 1. For example, 7 plus 1 equals 8. This means that the value of the expression adding 1 to 7 equals the value of the expression that is 8. More generally, of course, any positive whole number equals the preceding whole number plus 1. This is actually just counting, but it is important that the students recognize the incrementation relationship between successive numbers and also that relationship between a whole number and the numbers less than it. When we count up, we are incrementing. And by understanding the incrementation relationship, we always have at least one backup way to compute any addition. Why? Because from this relationship, we can always think of and express a number as a sum of ones. So in the worst case, we can just add ones, one at a time, to compute the addition. For example, we can think of 8 plus 3 as 8 plus 1 plus 1 plus 1. And then we add the ones to the 8 one at a time. 8 plus 1 equals 9, 9 plus 1 equals 10, 10 plus 1 equals 11. So 8 plus 3 equals 11. Why did I say a backup way to compute any addition? Because we will seek out patterns with numbers to be able to compute the additions faster in the future. But even if we face something that looks like a difficult addition, we now know that we always have a method to find the answer. This is a good place to begin discussing several concepts and their notations that are very useful in thinking about and working with equalities. The idea of expression, the equal sign, the plus sign, parentheses, the idea of value of an expression, the left-hand side of an expression, and the right-hand side of an expression as useful terms. By the way, if you have discussed grammar or the structure of language in your English program, You can connect this discussion with that one. We are here defining some ideas that make it easier to think about and to discuss and to work with numbers. Much like thinking about the structure of language and defining useful terms for English grammar helps us to understand and to read and to write and to work with English. Let's start with the idea of an expression. An expression is like a mathematical sentence. It is made up of numbers and operation signs, such as the plus sign for addition. The plus sign is shaped like a cross. It means we want to count together the value of the expression on the left and the right of the plus sign. The equal sign indicates that the expression on the left side of the equal sign has the same value as the expression on the right side of the equal sign. Depending on the context, an equality might be a statement, as in, we are stating a truth that one expression has the same value as another expression, or an equality might be a question, as in, we are asking whether it is true that one expression has the same value as another. The value of an expression is usually the simplest form the expression can take. This is often a number. For example, the value of the expression 8 plus 3 is 11. The value of the number 11 is also 11. Because 8 plus 3 has the value of 11 and 11 has the value of 11, we can write the equality 8 plus 3 and 11. 8 plus 3 equals 11. It is often convenient to reference each side of an equality as we're working with equalities, and so we commonly label these the left-hand side, or LHS, and the right-hand side of the equality. As we will see in great detail, if we modify the left-hand side and the right-hand side of an equality in the same way, then the equality will remain, even though the left-hand side and the right-hand side expressions might look different. Parentheses are often very convenient in showing an order of work in expressions that contains several operations. At this point, there are lots of practice opportunities to develop familiarity with simple additions. One good place to start is with additions adding up to 10, because these are generally useful to recognize subsequently in more complicated additions. For example, you can apply the understanding of 4 as a sum of 4 ones to work step by step through the addition 6 plus 4. Similarly, for 7 plus 3, and so on. But also, because you put the effort in Chapter 1 into becoming comfortable with numbers described by multiple digits, you can now already play around with adding those kinds of numbers. For example, 56 plus 2 is 56 plus 1 plus 1. That is 57 plus 1. That is 58. Take your time practicing these kinds of additions. As your student becomes more comfortable, you can experiment with slightly bigger additions by breaking them into smaller pieces. For example, 8 plus 7. You might think of this, based in your prior practice, as 8 plus 3 plus 4. And then using the adding ones method in 2 phases, you can compute the answer. In the next video, we will discuss some of the ideas developed in the subsequent sections of Chapter 3, and these will help with computing bigger additions faster.